So this whole chapter is about linear relations, but so far we haven't seen anything that looks like a line, and the adjective linear comes from the word line. So let's take a look at a couple of linear relations. I have y equals x plus 2 and y equals 2x plus 1. So a great technique for analyzing any kind of relation, but especially linear relations, is to create a t-table. And we're using x and y, so it's kind of easy to decide what goes on the left, what goes on the right. If you're using x and y, I always put x on the left, y on the right. If you have some other kind of word problem, sometimes it can be a little bit tricky to decide what should go on the left, what should go on the right. But for x and y, it's pretty straightforward. So what do you put on the t-table? Well, really, quite frankly, you can choose any x values you like, and then based on the equation above, you can decide what the y value is for any given x value. But if you want to make your life easy to actually graph this, you want to pick some sensible x's. And so let's just pick the values 0, 1, 2, 3, and 4. And that allows us to very easily calculate the y values. So when x is 0, we have y equal to 0 plus 2, so y is 2. When x is 1, we have y equal to 1 plus 2, so 3. When when x is 2, we have y equals 2 plus 2, which is 4. And you can see the pattern here. When x is 3, y is 5. When x is 4, y is 6. Let's just do the t-table for the other one before we look at any graphs. So again, why don't we choose the same values for x? We can choose 0, 1, 2, 3, 4. And in this case, we have y equals 2x plus 1. So when x is equal to 0, we have y equals 2 times 0 plus 1, which is just 1. Then when x is equal to 1, we have y equals 2 times 1, which is 2, plus 1, which is 3. When we have an x value of 2, 2 times 2 plus 1 is 5. When we have an x value of 3, 2 times 3 plus 1 is 7. And again, you can see the pattern here, 1, 3, 5, 7. And sure enough, when x is 4, y is equal to 9. So I've got, below those t-tables, I've got some coordinate axes set up. The x-axis is the horizontal axis, the y-axis is the vertical axis. And my background is a nice sort of graph paper background. I would suggest that you either go to a stationery store and buy some graph paper, or even much more easily just go online and do a search for PDF graph paper and print out some sheets of graph paper, and that'll allow you to graph these very nicely and easily. You don't really want to just kind of eyeball it on regular paper. You really do want to have some graph paper so you can get a nice accurate line and the points on that line. So let's graph the points that we just created in the t-table. So one thing that maybe isn't entirely obvious if you haven't used t-tables very much is that every row of the t-table is a point on the coordinate plane. We have an x value and a y value, so an x coordinate and a y coordinate. So that first point, the first row of that t-table, 0, 2, corresponds to the point 0, 2. So we have 0 on the x-axis and 2 on the y-axis. So that's that point right there. Then we have 1, 3. So that's going to be 1 unit to the right and 1 more up, so 3 units above the x-axis. Then we have 2, 4, so we're going 2 units to the right, 4 units up. And then we have 3, 5, and we have 4, 6. And you can see that those points all fall on a straight line. So this is the reason why we call this a linear relation. And we can go ahead and draw the line that passes through those points. And for some reason I'm getting a nice squiggly line there, but it is a straight line that passes through those points. Let's do the same for y equals 2x plus 1. We've got 5 points, starting with 0, 1. So 0, 1 is right there. 1, 3, we have 1 unit over 3 units up. 2, 5, we're 2 units over 5 units up. 3, 7. 3 units over 7 units up, and 4, 9. So you can see this is also a straight line. Those 5 points fall on a straight line. It's a slightly steeper straight line. And I've put arrows at the end of it indicating that this line basically continues on forever. Now, you might not believe me, so you can try a few more points, right? Put in some points, pick some x values that are a little bit beyond what we've done. Pick some negative x values. Pick some x values like 8 or 9 or 10 or higher. Obviously, you're going to run out of room if you pick some x values that are too big. Okay, so what about what we looked at last time? So if we go back up to the t table, if you notice, the difference between 2 and 3 is you're just simply adding 1. The difference between 3 and 4, also adding 1. It's consistent down the table, which we would expect because we decided that that's what it meant to be a linear relation. And then let's just do the other side too here. If we look at the difference between 1 and 3, we're adding 2. Between 3 and 5, adding 2, etc., all the way down the line. Now, what about the equations above it, y equals x plus 2 and y equals 2x plus 1? Well, this 2 here, the difference between an x value of 0 and x value of 1, shows up in the coefficient on x. And similarly, the difference between 2 and 3 in the table on the left, the plus 1, that shows up in the coefficient on x in this one. Now, there is no number in front of x. When there is no number in front of x, the coefficient is 1. We just don't write 1x because it's a little cleaner just to write x and to understand that there is a coefficient there of 1, even though we don't write in a number. So that's really crucial. What about the other number? So we have y equals x plus 2. Where does that 2 show up on the table? And y equals 2x plus 1. Where does that 1 show up on the table? Well, if you think about setting x equal to 0, all that's left is the plus 2. So this first point here, or at least the point where x is equal to 0, is referred to as the y-intercept. And the y value of that point corresponds to this value right there, so you can see it. And same thing over here, when x is equal to 0, that again refers to the y-intercept. And it's the point at which the line crosses the y-axis. That's why it's called the y-intercept. So again, you can see that this 1 shows up right there. So this y-intercept is sometimes abbreviated just y-int. And so that becomes quite a useful thing to note if you want to go back and forth between the equation of a line and the graph of a line. And so let's actually just do an example of that. So let's say we have a line and we'd like to know what the actual relation is. What's the equation for that line? So we need to be able to identify a few points, and let's take a look at a few here. So you can see there's a point right there, and that has coordinates of 0, 2. We have another point right there that has the coordinates of 1, 1. This point right here has coordinates of 2, 0. We can go to the left if you like, and we have a coordinate there of -1, 3. We could even go one further, so we're dipping down below the x-axis. The coordinates there are 3, -1. So if we turn that into a t-table, now with some practice you won't need to necessarily do this, but it's a nice skill to have. Let's just put those points on. Now when you're making a t-table, the x values really can be anything, but if you want to be able to analyze it, you have to do it in a very organized fashion. And ideally, you'd like the x values to be incremented by 1. In other words, you want them to be just 1 apart as you go down the t-table. So if we start with the x value of -1, so we've got -1, 3, then we have 0, 2, 1, 1, 2, 0, and 3, -1. It makes it a lot easier to analyze what's going on. And if you don't have the x values incrementing by 1, we're going to have to learn some other techniques. We'll see those later. But for now, all we have to do is take a look at what's going on with the y values. And so you can see you're going down by 1 each time. So that's consistent, which we would expect because it is a linear relation. And we can write the equation of this by paying attention to the fact that it's going down by 1. So that becomes the coefficient on x. So we can say it's minus 1x. And then where's the y-intercept in this case? Well, the y-intercept is right there, and that corresponds to this row of the t-table. So when x is equal to 0, we get a y value of 2, so that's the y-intercept. And that means that our equation has just got a plus 2 in it. And as I said, normally we wouldn't write the -1 coefficient, so it would be normally written as just minus x plus 2. So the minus is definitely important, but the 1 is usually left out, regardless whether it's plus 1 or minus 1. So that is the equation. And we could generate other lines in the t-table, or we could test it against other points that we identify on the line. And it's really important to look at lots and lots of examples of this. I've given you some fairly easy ones here. The textbook has lots to play around with, and I'll give you more in class.